Hi Guy, I'm Laurie from AI Elephant.
Hi guys, I'm Leo.
If you've been using large language models, LLM, over the past 6 months, you might have noticed a shift. The efficiency of simple prompt chaining, where you ask a question and the AI gives a single answer, is decreasing.
Exactly! But isn't AI supposed to be smart? Why are we spending more time debugging it and teaching it? Aren't we supposed to be moving towards a simpler future?
It is precisely because we are moving towards a more intelligent future that the AI's operational model must evolve. In this episode, we're going to deeply dissect Anthropic's agent loops and multi-agent systems architecture, exploring how Claude is evolving from a passively responsive chatbot to an AI agent capable of self-correction and highly autonomous execution. To understand why Claude excels at agentic tasks, we need to start with its training. The Anthropic team subjected it to extensive agentic practice, essentially giving it open-ended problems and allowing it to take multiple steps and use tools to achieve its goals.
Wait, this sounds like they trained Claude to be a programmer. And you emphasized a key point. Anthropic considers code to be the most fundamental skill for all agent capabilities. Why code? Specifically, why not searching or writing?
This is a counterintuitive but crucial insight. They believe code has a powerful spillover effect. If you can train an amazing coding agent, it becomes proficient at any other type of work. This is because all tasks, whether searching, planning a weekend, or processing data, can ultimately be abstracted into calling an API or executing logic. Furthermore, in many complex scenarios, asking Claude to directly generate the result is slower. For instance, if you need a detailed SVG chart or an Excel report, Claude struggles to generate the file directly. But if you have it write a Python script that includes a for loop to generate the SVG file, it's much faster.
Laughing so, they are teaching the AI to use programming to be lazy. Writing 10,000 lines of code is too tiring, so just write a loop. That's a great analogy. It means that through code, the AI gains the ability to execute tasks in bulk and repetitively, fundamentally boosting its autonomy.
This increase in autonomy necessitates an architectural change. Developers previously building a coding agent had to start from scratch, writing the loop, building the tools, and handling file interactions. A process often called reinventing the wheel.
That sounds painful for development. So what did Anthropic offer to solve this? Is it like a custom container similar to GPT's in ChatGPT?
They released a core tool, the Claude Code SDK software development kit. You can think of it as the core scaffold for a general-purpose agent. It pre-builds all the essential functionalities, including the core agent loop, tool execution, and file interaction. Developers are encouraged to use this SDK as the core framework. They then only need to add their custom tools and business logic through an interface called MCP, or Meta, contextual prompting. This significantly cuts down the development time spent polishing the core agent loop.
Got it. The SDK is a plug-and-play toolkit that allows every developer to quickly establish a closed loop. The old prompt chain was single-shot execution, but the new core agent loop is a continuous cycle of output. One evaluation, correction, 4 re-output.
Exactly. The leap from single-shot workflows to self-correcting agent loops is a huge performance gain. Agent systems now offer extremely high performance, surpassing traditional workflows in complex tasks that demand absolute quality.
Does that mean traditional workflows are obsolete? For example, if I just need a quick translation, do I need an agent to run an iterative loop?
Of course not. Traditional workflows are still useful when you require very low latency and only need Claude to provide the best single answer. However, for more complex tasks, the trend is moving toward workflows of agents. Imagine this. In the old workflow, if the step for writing the SQL query failed, the subsequent plotting step would be completely blocked. Now, the writing SQL query step itself is a closed-loop agent. It generates the code, runs it immediately, checks the output, and keeps iterating until it confirms the data is correct before handing control to the next plotting agent. This is a chain of agents, not just a chain of prompts.
Wow! That sounds like corporate department collaboration. What is the difference then with the even more advanced multi-agent system? Is that like a full team?
That is a key distinction. Workflows of agents are linearly dependent, multi-agent systems. At their core, involve multiple Claude instances working in parallel at the same time. Usually, a parent agent or orchestrator delegates the task to several sub-agents. There are two core design patterns for multi-agent systems. The first is parallelization, or MapReduce. Anthropic's deep research search product operates this way. A main agent decides to break down a complex search task, then creates 10 sub-agents to conduct the search simultaneously. This significantly speeds things up, quickly aggregating the results and returning them to the user. This applies to any task that can be broken down into subtasks.
That is easy to understand. Many hands make light work. What is the second design pattern? If multiple AIs are running, won't the context and token consumption explode?
The second pattern is context protection, and it's specifically designed to save tokens. Sub-agents are used to offload subtasks that would require tens of thousands of tokens. For example, the main agent needs to know the specific implementation details of a class in a large codebase. If the main agent loads the entire codebase, its context window will be instantly jammed. The correct approach is for the main agent to create a sub-agent, have the sub-agent look at the codebase, and only return a very small summarized final answer, thereby protecting the main context from unnecessary inflation.
That is so much like a human team. The main agent acts as a smart project manager, only looking at the results without having to pore over all the long raw data. It has learned to delegate and distill, letting sub-agents handle the heavy lifting.
Anthropic highlights two crucial best practices when building agent systems. The first is simplicity and observability. The core mindset is complexity is the #1 enemy of observability. You must always start with the simplest solution.
What are the common failure modes? Then, everyone wants to pursue the coolest architecture. After all,
The most common is overbuilding, creating a lot of dead weight. An overly complex system spends too much time talking back and forth with each other, like a bloated organization where efficiency is lost to high communication overhead. The second best practice, and the one I want to emphasize the most, is tool design should be UI-centric, not API-centric.
wait, I'm confused. Aren't tools just for calling APIs? Why design them based on the UI?
Because the agent itself is a user of the tools. You must put yourself in Claude's shoes. A natural mistake is having 3 separate API endpoints on your backend. Say, loading Slack messages, looking up a user ID, and looking up a channel ID. If you design 3 tools, the model has to make 3 calls just to understand one thing. But as a user, you want to see all the information presented beautifully, all at once. Therefore, you should create a single cohesive tool that packages all relevant information for Claude at one go. The goal is to minimize interaction and maximize context. Finally, let's look at the future. The future trend for AI agents is no longer just help me write code, but help me test my code.
Are you referring to self-verification capability?
Exactly. The most exciting trend is that agents will become adept at verifying their own work and closing the loop themselves. They can write a web application, then actually go open it and test it themselves, finding bugs without needing a human to act as Claude's QA engineer. To achieve this, the AI needs computer use capability. This means the AI will no longer just perform abstract operations in the background, but will be able to directly manipulate the computer interface.
This will fundamentally change the way we work. If the AI gains computer use capabilities, does it mean I can just say to Claude, tidy up the formatting of this Google Doc, and it can scroll, click, and edit text within the document just like a human?
Yes, once this capability is unlocked, it will open up all the other domains and channels that agents cannot yet touch, radically improving the user experience. The AI agent of the future is a virtual colleague capable of fully autonomous execution of complex tasks and end-to-end closed-loop control. To conclude our deep dive into Anthropic's mindset for building AI agents, if you only take away 3 pieces of advice, I hope they are: 1. Code is king. Training your AI with coding skills imbues it with the most basic, yet most powerful, autonomous action capability. 2. Prioritize simplicity. Start with a simple agent loop and only introduce multi-agent systems when absolutely necessary. Be wary of the overbuilding trap. 3. Design tools as a user. Ditch the API mindset. Design your AI tools like a user interface, ensuring information is presented to the agent efficiently and all at once.
From today, our mindset towards AI must shift from tool to efficient manager. Thank you to all our listeners for joining us to peek into the future of AI agents. If you have any thoughts on AI architecture or our analysis today, please feel free to leave a comment and interact with us.